Oh, look at that. If that's actually legit, that was really fast.
Oh, that's true. So we might not see it streaming on my side then.
This is
On Zoom at least.
I'll see if anybody is. Okay. This is
Yep, we are live.
that's funny. Because like I have full control over I can see the chat and everything.
So we might individually need to download this as well for
I
the
mean
two of
maybe.
us.
I think a lot of it is just who has control over the whole thing, but it's kind of interesting to play with. Um so, hello. Welcome in. I'd like it or Justin's already asking about the M7, which I think no, that's not what Tanya put in our deck. That's a film interruption. Um,
Yeah,
do we, have we looked at that? Have you looked at that at all? Because I haven't looked at it yet.
not yet. It looks like there was. Well, I guess we can go into intros while. I guess I will need JK viewer.
Yeah.
Jokes
Well,
on me.
anyway, while he's doing that, we'll look into it. But today's kind of informal. I'm testing something new. I downloaded OBS, which gives me a little bit more control over these streams. And like right now, I can see the chat, which is really cool. Which is something I couldn't see before. Lets me put little logos in the corner. uh, so it's kind of cool. And but today we're gonna discuss what happened over the weekend and kind of talk about the pitfalls of using EPAM monitor and solar orbiter for predicting what's going to happen here. Um, it is a nice tool to have. It's cool that we have all these tools at our disposal, but we have to be careful with them because they aren't designed for aurora chasing. They never were. I don't think they ever will be. But we can
Yeah.
use them to make informed decisions on, you know, if we want to travel somewhere like that. So that's kind of the gist of today's little thing here. And Justin says, "Yeah, OBS Streamlabs is cool." Yeah, because for streaming Guitar Hero, yeah, because this is definitely a gaming thing. I noticed there was
Oh,
a lot
those
of
were the
those were a
days.
lot. There's a lot of gaming themes. I was tempted to put a gaming theme on this, but I'm like, no, let's just keep it simple right now. I could put some a title under Christian's face here and give him like a weird name. Maybe that's what's gonna happen. But yeah, we'll
I
see.
mean, I guess I can't see them on my side, so that means I have no idea what you're putting up. So
Oh, that makes it even better. It's like
I
a
guess
secret.
if you have to.
So Tanya says not much from the M7. So
Yeah, I have JK viewer up now too. There was almost no nothing really. The
okay.
flare looked mostly empty. Small pressure wave, but it doesn't look like anything was ejected very much. So I'm gonna go with no.
Okay. There you go. There's your quick and dirty answer. I
I
guess.
have the video up though, so once we actually get to that point, I can at least
Yeah,
share it.
you
But
can share it now if you want.
well, I mean, in that case, let's
I
start with the
gave
data
you
stuff.
control.
Yeah, this is the base imagery in 211, and we can even zoom in here, but really, mostly pretty much unimpressive. Pretty slow. A little bit of dimming, but I don't think that was indicative of an actual flare, or an actual CME, rather. We'll see in Glasgow, though.
Yeah.
So, as far as what happened, so we had, yes, burned by the solar orbiter data, which I
Mm-hmm.
kind of guessed was going to happen, but you can only get so far. So let's check out real-time solar wind data. Zoom in a little bit. So we had, yes, so first CME X3, it was a very, very, very side clip. I mean, it was even uncertain at this point if it was going to show up. I had doubts. We had also a kernel hole and a CIR arrive around the same time, or at least forecasted to arrive around the same time. We've got some mini shocks here, which I'm going to go ahead and say is from the CIR likely, or something close to that. And then a clear CME eruption at the very beginning. Oh, man.
What did you
Or I will
do?
click a button and it will disappear.
Tisk tisk. We're
Anyway,
we're professionals here. Come on now.
Since when? I never signed up for that.
I know.
Anyway, so then we had what looked to be, oh, that's 1010. Wait, what is going on?
It's not giving you the dates that you want. Oh, that was good.
No, there. That was weird.
Weird.
Anyway,
Anyway.
so mini shock from the CIR, and then we had a BT jump to about 24, 25, 26 nanotesla, mostly oscillating BZ. We had a few good periods, but I believe those periods were for mostly the Scandinavian region for dark. So it's not like we got to see much of that. I'm pretty sure, and I actually we're both pretty sure at this point that this was from a CME East limb shock and the CIR that kind of commingled or mixed. So it had a little bit of a stronger impulse to it compared to at least the first major impulse on Solar Orbiter, which was slightly closer to the east, so it got a little bit more of it. But then we had mostly nothing. It just faded off. There was no flux rope, so no organized magnetic field. And then we come to the smaller area over here, where we had another impulse from the X3, or sorry, X1. So it would have been the 28th. Actually, it was like pretty close to midnight, if I remember.
Yeah, it's like 11:30 Central.
Because then I remember waking up to, BT is 24, and then I wake up and, oh, no, it's 14. And within about 6 hours, it goes all the way back down to 10.
But if I do remember correctly, even in the Solar Orbiter, it only saw about 6 hours worth of anything anyway.
Yes, the only difference was Solar Orbiter here, so
Yeah.
much bigger impulse, up to, it looks like about 35, almost 40. We did have a flux rope as well. Oh, she's got the dates zoomed in for this one. Cool. So we've got a negative, an SWN flux rope basically was the one that was seen for the first one. And then the third one looks like not much of anything.
No, that just kind of looks like a mess to me.
And yeah, just a very organized mess at that.
Yeah.
Which, to be quite honest, was pretty much what we saw here at Earth anyway. And even less so because we had, again, 23, what did we hit? 24 for max? And only 2 or 3 periods of some negative BZ. The magnetosphere was already perturbed from the hits before and this one, so it did some nice aurora. And I want to say the eastern half of the country got like a early morning show. I think it was more Canada though. And then BZ again just stayed mostly positive. So really a non-event from both regards. Sadly, there wasn't really too much to look at there.
So yeah, that's what happened.
So that's solar wind data.
But what we saw from this was a lot of EPAM chasing and a lot of Solar Orbiter chasing. And so that's kind of what prompted the next part of this little stream and the dangers and pitfalls of that. I mean, it has its purpose, but it needs to be used wisely, I guess you can say. So let me pop this over here. See, this is
going to be a pretty good session.
Yeah, this is where I'm getting used to the two different concurrent screens. But so I made this little slideshow called EPAM and Friends, a story. Because I like stories, so we'll have a story. And I made this little thing earlier because Tanya was joking about black box warnings on drugs, and since aurora chasing is kind of like a drug to us. I figured this was fitting, and maybe it should come with it. So I'll just leave that up there. You can read it. Because we all get these feelings of
That's funny.
Confusion, frustration, mistrust, migraines, insomnia. The thing that I want to stress here is that, especially in the world of space weather, this is like the Wild West. People are going to be wrong a lot. And it's okay. It's okay to be wrong, especially in science. That's how you grow. It's how you learn. What I've noticed, especially in today's age and world, is that if you're wrong, then automatically you lose all your credibility. You don't know what you're talking about. You're just like, it has this very negative connotation. And I think we need to change that a little bit. It's perfectly fine to be wrong. The point is, you go back and look at it. You look at why things were so off, and then try to learn from it. So that's kind of what I wanted to preface this with.
Well said.
Yeah. So, okay, let me go here. So, we're going to start with the EPAM. What it means is it's the electron proton alpha monitor, and it's on the ACE satellite, and it monitors low levels of low energy particles at L1. I think it also does the high energy ones too, but we're more concerned with the low energy ones, because you will see increase during radiation storms and ahead of CME shocks. Increase in levels can be seen as a CME approaches Earth. So this is the main reason why people EPAM chase, as we've grown to call it, because if you see a rise in the EPAM, you're like, oh, the CME's on its way. However, there's some pretty serious limitations to this, and that's because of radiation storms. Basically over the entire weekend, we were under an S1 or S2 radiation storm, due to the different flares that were going on, the CMEs. Like, it just created this whole particle mess, and it becomes very hard to figure out where a CME is in that mess versus what is just the radiation storm that's going on. So you could get rises. You could get rises and rises and rises, and you won't, until after it passes, like all of it passes, you might not know exactly what you're even looking at.
And we've seen this multiple times now, especially with the X flares we had
Yes.
2-3 weeks ago that didn't produce or do anything, but we saw an EPAM as they landed the shock there. Yeah. This has been common lately.
So that's especially these. And this diagram here explains why the east limb shots are difficult. This is a weird. I'm gonna preface it. It's a weird. Let me see if I can have my mouse here as a pointer. So this shows the east and west kind of orientation of the sun, which is how we look at it. The east is over here, west is over here. However, it's supposed to be kind of flip-flopped, how we're used to seeing it. So they have these diagrams opposite than what's this image. So like right here, you see west 53 degrees. So this would be like one of these solar or energetic particle events from the western limb of the sun. This is the eastern limb. This is more center. And you could see the difference right away. We've been seeing a lot of this over here because of all these east limb events, where you get these slow rises that just rise and rise and rise, and then eventually you'll get a shock. Sometimes you don't, though. So some of these east limb events, like, you won't see a shock. It'll like get to a point and then just drop off. If you get one from the west, you get the shock pretty. You'll just get this not heavier but faster rise. And then more in the middle, you get more of a middle kind of orientation. Makes sense. So that's one of the things I wanted to get across about using EPAM, because depending on where the event is coming from, you're going to see a different signature. This diagram here shows the different types of SEP events, because you get these impulsive ones, like from flares, and then you get the gradual ones, which are CMEs. So you see the CME cuts across these different these lines here are called the Parker spiral lines. Those are the magnetic lines that are coming off the sun as it rotates, kind of like a sprinkler head. Like it's shooting straight, but the way it's moving, it looks like it's bent. And these particles are trapped amongst these lines. So if you're trying to travel eastward up that, you have to fight against it, which is also why you get this slower rise versus the more extreme rise on the west, because you don't have to fight it as much. And you see it's a lot more spread out. So this is kind of what the signatures look like. You get like these spikes in the more impulsive events versus the gradual ones. So that's without going into too much detail about what these are, because we could spend an entire hour or more on particle events, I just wanted to sort of get over like what EPAM is and what you're seeing, because this is what you're seeing. But particle events they don't cause aurora, so we're not really that interested in them. This is more for satellite systems, people that are in space, things like that, things that can do a lot of damage.
Just like the shock WSA animal models.
Yeah, which we'll get to. All right, and then speaking of that event, so this right here, Tanya was awesome enough to pull the EPAM data and label where the flares were, as well as the radiation storms. And you can see pretty clearly here that EPAM was on a rise a long time. So if you're looking at EPAM and you're looking at, especially in just that little 24-hour window, it's just going to look like it's just rising and just rising and rising and rising, and you like, when is it going to end? You don't really know, because there's a lot going on. If you zoom out, like I think this is like almost a week worth of data, then you can really start to see the trend lines, where the shocks were, and then you can pick out where these shocks actually happened. But the gist here is when you have multiple things going on, especially radiation storms, and I was trying to explain to some people that asked me questions, it's like, I wouldn't be EPAM chasing this event at all, because we're under an S1 radiation storm, and that eventually went to S2. So you don't really know what you're looking at, to put it bluntly. So it turns, as frustrating as it is, it turns more into a wait and see event. Wait to see what happens at L1, which is something that for us Aurora chasers, we push all the time, because that's going to be your telltale, something is here, something is happening, versus trying to forecast it at this level. When you have quieter events, like one-off CME or something like that, yeah, EPAM can be helpful. But these compound events get really messy really quickly. So that's going to take me to Solar Orbiter. This is another favorite of the Twitter world. It's a great instrument to have. It's not designed for Aurora chasing. It's really not designed for... It's got different missions. I'll be honest, I don't even know entirely what all of its missions are, other than studying the sun. But a couple key things here. We can use it to some degree. Like when it's 15 degrees of the sun-earth line, which it was the other day. I think it was 13 degrees. It can see a CME. And what that is cool is that we know something is on the way at that point. And we can get a good look at its magnetic structure. However, there was still 86 million miles between, at least I think if I forgot that right, between Solar Orbiter and Earth. So there's still a lot that can happen in that space. In fact, that's kind of what happened to us and why some of us got burned by Solar Orbiter, because we didn't see nearly the same type of shock or anything that Solar Orbiter saw. And it was only 15 degrees off at the sun-earth line. It becomes a lot more helpful. Actually, I think it's more helpful when it gets on kind of the other side of the sun, so we can get a better view of the far side. So that way, when we get these full halos that show up in LASCO and we don't know if it's front-sided or back, we can use Solar Orbiter to help make heads or tails of that. Which right now it's in our frame of view, so we're using it for this purpose. So the point is, what happens at Solar Orbiter stays at Solar Orbiter. Just keep it at that. Let's not try to use it to predict how strong something's going to be or anything like that, because it can definitely change, and we saw that on Sunday. And here, actually, this is a pretty cool thing, because this shows the 3 different shocks, both at Solar Orbiter and in ACE. And you can see where they were in comparison. You can see how, like, this is the one that got everybody, because look at the like the strength level versus what we saw. It's like,
would have been nice to see.
Yeah.
Even for a few more hours.
Yeah. So it's a great tool to have, but for trying to predict aurora off of it, I would just be very, very leery and careful about it. Just use it as, hey, it saw something, it's within 15 degrees of Earth, that means we will likely see something. What that something is, we will find out at L1.
As always, L1 or bust.
And
I feel like every one of the morals comes back to that.
Yeah, for my last point I'm going to make today, because this is already showing up in the Twitterverse, is the modeling, the CME modeling, bulk modeling versus shock modeling. There's a number of people out there who love to use the shock model because it shows it's wider, for one. Usually it's more aggressive, so it looks like we're going to get hit by something like crazy, but it's just the shock. And the purpose of that is for solar energetic particle forecast. That is for our operations people, for satellites, for people in space, things of that nature. What we're interested in is the bulk modeling, which we can call the heartbreaker if you want. Because as you can see, I mean, this is the same event. This is for a filament eruption, and you can see side by side the difference between the two models and how drastic the difference is. This bulk modeling basically says it's going to miss us. Maybe we'll get that very, very tiny clip. I don't know. Probably not. But if you look at the shock over here, it shows that it's going to hit us. So yeah, I wanted to get that in here because that I see this all the time on Twitter, and I think it needs to be addressed. We do not want to use shock modeling for trying to even like predict how good an aurora show is going to be. I mean, even if we do see the shock, that initial energy is just, it's not going to last that long. Unless, and then it's got to be timed right. Like if that happened at noon our time, in the middle of the day, okay, that's fun. It'll be gone by night. So anyway,
which is exactly the X1.
Yeah, exactly. It was pretty much
didn't
gone.
even make it to our nighttime.
So let me escape out of here because I think that was my last slide. But that was kind of what I had on this. I'm trying to remember if we have anything that I wanted to add into this, but I think we covered it. Let's see if we have any questions in the chat at all. But we wanted to kind of keep this one a little short and sweet, because basically just we
Could be
wanted
another
some,
fun meeting out.
Yeah, we just wanted to get some clarification going on, because this event was neat to watch, but I could feel the frustration from people messaging me, like, should I go out, should I go do this? And I mean, I was in Chicago, so I wasn't going anywhere anyway, but let's just, the FOMO is a real thing, and I can see it happen in real time on the internet. Like as soon as somebody posts something like the solar orbiter data or whatever, and it looks like it's going to be strong, and even if it's like you catch the bug, and you're like, well, maybe I should go do something about it, and but you have to get in your mind, it's like take a chill pill. Think about it. Like, these are still glancing blows, and glancing blows are glancing blows. Sometimes we've had some good ones, but these were particularly kind of far to the east, so they were always kind of iffy to begin with. The first one we both had more faith in because it had the CIR and coronal hole also with it, and that was in the model. Like, you could see the density plug there. So that one, I had a little more faith in, and it ended up being the better one, but it still wasn't like great. Like, I wouldn't have
not like we got anything much out of it.
7 hours for that. I would just wait until it got into a more favorable position. So that's kind of my piece on that. Speaking of, since I'll ask you, I heard you said those sunspot regions kind of have lost some of their craziness.
Yeah, I'm really not seeing anything fun. I mean, I guess we can go ahead and jump in.
Might as well
to what those are.
Yeah,
but I'm not seeing anything potent right now.
Which is kind of a bummer, because I know all of us were probably sitting here wondering, like, well, maybe it'll get better as it rotates into Earth view, but I guess
it stayed potent for a little while, but that region, the entire area that was more potent than really the rest of them, really faded fast. Okay. Let's get the magnetogram quite a bit down here. So really, I mean, there's quite a few groups. This is the main cluster that we were seeing. There is some growth here, so I'm seeing that as a little more promising, but it's all the same polarity, so it doesn't necessarily matter, but it is getting more complex. These are all just dying. There's not really any potency left in these 5 here. And then we just got a ton of little regions and some little growth in betweens here too. But I do not see any significant polarity mixing or anything that would cause high-end X flares at this point. I believe this was the region that flared for the M-class just now, and it has some growth in the central penumbra. So this region could be a little interesting. This could start mixing and get you a nice delta region, which we'd see some flares there. But ultimately, as far as what the sun is looking like right now, peppered with sunspots, but none of them are terribly potent.
Okay. Yeah, I think Tanya messaged. She said 3878 may have a small delta, but which
Yeah,
one's 3878?
I'm assuming the region that flared,
Probably. Yeah.
and I wouldn't say it's quite a delta yet. There's no connection. Yeah, the penumbra are distinctly separate for now, at least.
Okay. Well, I guess we'll just
There
wait and
might be
see.
something forming here, and again, there's plenty of opportunities. I mean, it's definitely. Oh, actually, that's weird. It looks like a limbing effect almost. Oh, wait, this is East Limb too, right?
Yeah.
Oh, okay.
Yeah.
That makes more sense. I was gonna say this looks like it could be a delta, but I don't think it is.
East Limb. East Limb of
Mm-hmm.
fun. That's been the
Yep.
story of our
So
life lately is East Limb.
M-class flares likely, and I mean these are pretty big sunspots, even though they're mostly just individual, large, simple ones.
I
So,
mean
but
that
there's a lot going on.
I mean that
This would be
one
great for imaging right now.
that one what was it? The one that gave us that head-on hit basically was kind of just one big sunspot that wasn't super complex anyway, if I
Yeah,
remember correctly.
it
So,
had some vertical polarity big sync if I'm not mistaken,
yeah.
but beyond that, it was pretty small.
So, you never know. You never know. They change constantly. But we figure we cover that. But hey, look at that. Right at a half hour. It's kind of what we wanted to keep it at today. Short and sweet, but hopefully you got something out of that. Just that the whole thing is just be careful with all of our things that are up there. They're great tools to have. I'm happy to have them, because it does make even if it's convoluted, like you have to piecemeal together, data and then try to make your own informed decisions about it because none of this is designed for aurora chasing. It's nice to have it because it does kind of give you a little bit of heads up for things that might happen, but just don't fall into the FOMO trap. That's what I'm gonna say. Don't fall into the FOMO trap. Keep your wits about you. Look at things with a critical eye. Reach out to people that you trust with it. That's my take.
Yep. We'll get more opportunities. This isn't the end. We've got the whole
No.
entire down cycle still to go, at least another 2-3 years of some activity.
Yeah, absolutely not. So yeah, it's fun. It's fun. Solar Maximum is fun. Keeps us busy.
Much better than last maximum. I'm telling you, we never had any near complex events, like frequently at least this many complex events.
Yeah, I mean, it's crap. I was looking back on our stream, like our live stream list, and just how many X flare ones we've had just in the past 2 months.
Mm-hmm.
I'm like, that's kind
5,
of
6 now.
yeah. I will take it, even if it makes me tired and wiped out. But it's fun. So we have lots to go. Yeah. So anyway, hope everybody enjoyed it. Hope you guys have a good week. I'm off to Canada this week, so that's why we're doing this midweek type of thing because I don't know how much of a chance I'll get up there to do something like this. So we wanted to make sure we did something before taking off. But yeah, because we love you guys. We love you guys being here. We do.
It has been fun.
And now that I have OBS, we're gonna become a little more fancier. I'm gonna have titles and stuff
Captions
soon.
and streams, titles.
Oh my! So the real key here is if I'll be able to hit a button to stop streaming, or if this is gonna go on and people are gonna be like, "What are they talking about?" I was like, "Oh, I forgot to hit stop streaming. Oops, my bad." You noobs.
That'll be a new fun thing to go through.
Yeah. All right. Anyway, we will sign off.
Thanks, everybody.